So to start off this question, you would actually set both of these functions equal to each other, because we're looking at where these functions cross, at what x value these functions cross. So you would do x squared plus 2, which is that function there, equal to x plus 2 all squared minus 32. And then just expanding our brackets out here, we got x squared plus 4x plus 4. Simplifying with common terms, I have these highlighted in green. We got x squared and x squared on this other side here. So if we were to move that to the other side, you would add negative x squared to both sides. And you can see that's just equal to 0 for these two terms. And then for our yellow terms here, we do positive 2, and then we move 28 over to the other side. So 28 plus 2 is equal to 30. And we can't combine anything with 4x, so we'll just leave it. And the whole goal of this is to try to isolate x by itself, because that's what we're trying to find, right? So now we have 4x is equal to 30, and then we can just divide by 4. So then x is equal to 30 over 4. And then x is equal to 15 over 2 is our final answer, because we just reduce it by a factor of 2, right? And then if we want to know the y value, we know the x value, which is just 15 over 2. So it doesn't matter which equation we plug 15 over 2 into to get the y value, as long as it's one of the two functions that we began with, right? So we have y equal to x squared plus 2. That's just the one that I chose, which is just this one here. And so y is equal to 15 over 2 all squared plus 2. And so that's equal to 225 over 4 plus 2. And so our y value isn't something quite nice. It's a decimal. So 58.25 is our answer. And if we were to go to Desmos real quick, y is equal to x squared plus 2. And then x plus 2 squared minus 32. We see this is pretty hard to, like if you were to draw a graph, this would be pretty hard to find the intercept. What we do eventually see, it happens over here on the right at 58.25 and 7.5. So our x value is 7.5 and our y value is 58.25. And that's what we got here. At what x value do these graphs intersect? So this one's a little bit different, but same sort of thing. Set them equal to each other, right? Isolate for our x's on one side. So we see that nothing really cancels out, right? But we can just choose a side. We'll say we want this side to be equal to 0. So we move the 3x over to the other side. That becomes negative 3x. And then we move the plus 3 over to the other side, and that equals a negative 4. So then we have 0 is equal to x squared minus 3x minus 4. And then using our previous method, we can factor this, right? So what two terms, so we'll say, okay, so this beginning term of the x squared is 1. So we'll do 1 times negative 4, which is obviously still negative 4. So what two terms multiply to negative 4, but then add up to negative 3? And we find that after some trial and error, you would get negative 4x and plus 1x. So negative 4 and 1 would be those two integers, those two numbers. And then we can just factor those out. So we have x over on this side, and we have, well, we just factor out a 1, I guess. You could just put brackets around those. And we factor out x minus 4 from each of these brackets here. So then we have x plus 1, and then x minus 4, similar to what we did earlier. And then, so thus the x-intercepts are x equal to negative 1 and positive 4. And how we found that out was that we looked at this fraction here. We saw that if we were to move that, if we were ignoring the x minus 4, if we were to put that negative 1 onto the other side, that'd be x equal to negative 1. Another way of saying that is that if x equals negative 1 here, this whole term would be 0. And so that's what we're trying to find, is which x values make this expression 0. So that would be negative 1 and 4. And so we know the x values, so you can just use either function to find the y value, right? Same as before. When x equals 0 also be an answer? It wouldn't, because if you were to plug in 0 for x, it'd be 1 times -4. And so that doesn't equal 0. So that won't be a solution. We're trying to find which x values make this 0. The x value, and then we have the y value. So that's just plugging in the x into either of these equations. So we have x equal to -1. The y value would be 0, because -1 times 3 is -3, and then plus 3 is 0. And then for this one, we have x equal to 4. So we have 4 times 3, which is 4, 8, 12, plus 3 is 15. So that's what we got there. And yeah, it doesn't matter which function we plug it into. We'll get the same answer. I guess the most important was trying to isolate for x here, factoring it out. Sometimes it won't be too nice, and we'll see in a moment here that factoring probably won't be an answer to this question, because it's kind of like an ugly equation in some cases. So we'll see here, I think, yeah. So at what x value do these graphs intersect? So we have these functions now. But now that we see, if we were to isolate for x on one side, put all the terms on one side, we have 0 on this side here. Now we can't really factor it, right? If we were to do that method that we did earlier, that aside, you would come up with some kind of ugly answers. You can always use the quadratic formula for any two functions if you're trying to like isolate for x on this one side here, like this. Our 2 would be our a, our -5 would be our b, and our -4 would be our c. Using the quadratic formula and some ugly kind of math written up here, we have x is equal to negative times -5, because negative times -5, -5 was our b value, right? So that becomes positive 5 after we simplify that. And then we have plus or minus square root of 20, or yeah, so that's 5, -5 squared is 25, minus 4 times 2, because 2 is our a value, and then times -4, because c is our -4 there. And that's all going to be divided by 2 times 2, because a is 2. So we have x is equal to 5 plus or minus the square root of 57 once we add all those terms up. And that's all going to be divided by 4. And I realized that I didn't put that square bracket in, but you'll see here that I did in the next line. So that's just equal to, solving for that, we get x is either equal to 3.14 or negative 0.64. I'm too lazy, but you just plug that into our functions that we got earlier, either f or g, and we would solve for our y value. These websites help a lot with graphing. Desmos, like we showed earlier, is quite helpful. I use this one a lot. You can do MATLAB as well, but Desmos is definitely the easiest one, and it's all online and pretty simple to use. And so here's just one sample question. This one's a little bit simpler. So at what x and y values do these graphs intersect? So our x value would be -1 and our y value would be -1. So that would be one of the answers, is -1 for x, -1 for y. Another one would be 2 for x and 2 for y.